In the northern hemisphere, the days grow longer and the nights become shorter as summer approaches. As winter approaches, the days become shorter and the nights grow longer. The longest daylight and the shortest night are during the summer solstice. The winter solstice is the day when night is the longest and day is the shortest. Today, you will investigate how you can identify seasons using an Earth and Sun model along with a temperature sensor. How can the apparent motion of the sun and seasons be described, predicted, and explained? This is Seasons and Temperature. Have you ever been asked why it's hotter in the summer than in the winter? There are a lot of misconceptions out there, and some answers may surprise you. Let's take a look at how students from elementary to college level have answered this question. Humberto says, I think it's hotter in the summer than in the winter because the Earth orbits the sun in an elongated elliptical path, and this is what causes Earth's distance from the sun to vary. We are closer to the sun in the summer than we are in the winter. Wakas says, I think it's hotter in the summer than in the winter because the Earth is tilted 23.5 degrees. In the summer, the northern hemisphere is tilted towards the sun, so therefore it is closer to the sun. And Christine says, I think it is hotter in the summer than in the winter because the Earth's axis is tilted and the sun's rays hit the Earth at a steep angle. The light does not spread out as much, thus increasing the amount of energy hitting a given spot. Also, the long daylight hours allow the Earth plenty of time to reach warmer temperatures. So who do you think got it right? In this activity, you will create a model of the sun and Earth to investigate the phenomenon of seasons. All right, so let's talk about what you need for this setup for today's activity. You're going to need a meter stick or a tape measure. Either one will work. You're going to need some masking tape, and I'm using a globe. It's just easier for me to use in terms of reference for the equator, the northern hemisphere, and the southern hemisphere. You could also use a beach ball or styrofoam as well. You're going to need a temperature sensor, and when you place it, this is really important. You want the part of the probe that actually collects the data, which in the temperature sensor is the very tip of the probe. That's where it's going to be collecting your data. You want that tip to be halfway between the equator and the North Pole. So make sure you have that placement. Again, the tip of the temperature sensor needs to be between the equator and the North Pole. All right. And then, of course, you're going to need a model of the sun. For this activity, you need to make sure you have an incandescent light bulb. Incandescent light bulbs give off heat. Your LEDs are not going to give off substantial heat for this activity. They also get very, very hot. So it's important that you use a lamp clamp, something that allows you to hold the light without touching the light bulb at all. You don't want to grab onto this part either. Ideally, you have a partner that can hold the sun for you. For today, though, I was able just to utilize a clamp and a rod stand here, and that way I can get my sun model prepped. All right, and of course you're going to need your Spark View software. Now let's get started. Okay, so let's get on to data collection. I want to point a few things out for you. We're going to be focusing our attention on the northern hemisphere today in terms of what's facing away and towards. And I'm going to have the temperature sensor facing directly towards the sun. I have my meter stick because I need to be half a meter, 50 centimeters away from the sun. Our first run, you're just going to have the globe straight like this, so the equator is running across the middle. The second run, you're going to tilt the northern hemisphere away from the sun, about 23.5 degrees. I like that you can use your masking tape roll here as a great globe stand. Works great, so nothing's flopping on you. And then the third run, we are going to face the northern hemisphere towards the sun. And it's going to be stationary for all three runs. All right, so I am going to get it set up so it's straight. Temperature sensor facing the sun. I'm going to turn on the sun and do my first collection of data. And I'm going to do a temperature over time graph. And there we go, first run going. Okay, we're about halfway there. Ten more seconds. Okay, and I stopped my data collection here. I want to point something out to you that just happened to me, and this might happen to you in the classroom, so this is a really good learning experience. You got to be careful when you start and stop collecting runs of data. You can see that it's on run 3 because I accidentally tapped a little too quickly. So run 1 was the good one. We want to keep that. I want to get rid of run 2 and 3 because ideally I just have 3 runs to worry about so I don't mess up my data. Let me show you how you can fix that. I'm going to go to Manage Runs, and I'm going to delete last run. This means it's getting rid of run 3. I'm going to do it one more time. Delete last run gets rid of run 2. And done. So now I've got clean data to work from. All right, so let's do our second round. I'm going to tilt the northern hemisphere away from the sun for this one. Make sure I've got a good angle here. All right, let's start recording the data. Thirty more seconds. Ten more seconds. Okay, for the final run, I'm going to tilt the northern hemisphere towards the sun. Check and make sure I got that at a good angle. And let's collect our last run. Thirty more seconds. All right, excellent. Now you've collected all 3 runs of your data. Okay, so let's talk about data analysis. I'm going to bring your attention back to the SparkView screen. You collected 3 runs of data, If you click on each run, you can pull them up, and when you have all three up, you can interpret the data. You can start to understand why we're talking about seasons and temperature here. Maybe you're gathering some ideas on what seasons we might be in at each one of those tilts. I find it helpful to rename my runs so I know exactly what part I was at in the activity for each run. So let me show you how to do that. I am going to click on the Experiment Tools bar here and Manage Runs. Now I'm going to go to Choose Run to rename. And one, I'm going to say Sun facing equator. Let's do the second one. This is when the northern hemisphere was facing away. So NH facing away. And you could put from sun if you want, but this lets me know enough that I was facing away. And now I'm also going to rename my third run, which was northern hemisphere towards sun. Okay, so when you save your data, if your activity is wrapped up, you don't have time left in class or at home, you can pull up this data file. You knew each run you had, and between the data you've collected on temperature change in each one of these directions and with the information that was in the introduction of this video, you can now go forth and complete the questions in your student activity sheet.